Hello, my name is Jay and I'm an applications engineer here at Emerson NI. In this video, we're going to be looking at how we can do channel mappings within VeriStand. Mapping channels is an important step in configuring your real-time test system as it tells VeriStand how to connect your data between models, real-world I/O, custom devices, or any other channels you might have in your system. There are multiple ways of mapping channels in VeriStand, and we are going to go through each of them one by one in this video. In front of you, you'll see one of the shipping examples that comes with VeriStand. It's called sine wave delay. In this project, we have a couple of simulation models that are generating some data and applying it to a sine wave. For the purposes of this demonstration, I have also added one of our multifunction I/O modules, our PXI 6363, and I've configured an analog output channel on that. And this view is actually the first place where we can change our channel mappings. You'll see here that there's these orange wires connecting my various models and other channels in my system. This is a representation of the channel mappings that you currently have in your system. Now, let's say I wanted to change these. For example, if I wanted my sine wave output here to instead connect to my analog output pin, I would simply delete this wire and connect it up like so. If I then save and deploy that project, my random sine wave would now instead get deployed and outputted onto my analog output channel. And you could do that for any types of channels you have here. Let me just undo that. The second way of mapping channel is using the Systems Explorer, specifically the channel mapping tool that you find in the System Explorer. There's multiple ways of getting to this tool. You can, for example, go Tools, Edit Mappings, or click on the dedicated button here, Configure Mappings. When you click on that, it opens this window. I like to resize this window just to make it a bit easier to see, something like so. In this window, you have your sources, all the various outputs in your system on the left, and your destinations on the right, the imports or any destination channels. And you could click through and view those various channels that you have here. So if, for example, I wanted to take that same sine wave out that I had earlier and map it to my analog output on my PXI card, I could do that by selecting out on the left and then the corresponding channel on the right. I can then hit the connect button that you see here, and that will add an extra line to the table I have below. This table is showing all the current mappings that are available in my system. And I could go through and one by one map my different channels outputs to the different imports. If you had any aliases, you could also use those and map those across here. And there is also a search window that you could use if you want to search for a specific channel. Now, that's great, and I can do that. However, you can imagine if I've got a very large system with thousands of channels, that it might be quite time-consuming to go through and modify those. So that brings me on to the third way of mapping channels, and that is to use a mappings file. You can create a mappings file by hitting the save icon in the top left. And what this will do is export your current mappings. So we select the file path, okay. Export your current mappings, and that will export and create a text file. I won't do this now because I've created it earlier. But the text file that gets created will look something like this. And you can see there is the same syntax we saw in the list, where we have our sources on the left and our destinations on the right. Now, this is a standard text file. So what that means is that any application that can generate or build a text file can build this mappings file. This means it is possible to script the creation of this mappings file as well. Now, how do we use this mappings file? So I've got it saved on disk. I'll go back to my VeriStand window and my mappings tool. I will just disconnect the channel that I just created, so disconnect. And what we're then going to do is we're going to import or open that mappings file that I just showed. So we'll click on this window here, point to the right path, demo channel mappings, okay, and hit import. This will read the text file and import the different channels. Now you notice that some of these are highlighted in red and this last one is in black. These in red are saying that the destination is already mapped. What that means is those channels already existed in my system. And as you see, that is correct. So what I'll do is I will hit import and it will import that last line that we just showed there. Hit exit and you can see it added it to the list that we were just looking at. I'll hit OK and then close my system definition file, save it. And what you might have seen there is that as I saved it and closed my system definition or system explorer, you see that this window updated as well. And you can see it added an additional mapping here. So now my sine wave output is mapped to this simulation model here, but also my analog output channel that I showed you earlier. In VeriStand, it's possible to map one output channel to multiple different imports. So one source to many destinations. This is very helpful when you're configuring a large system where you might have signals that you want to go to multiple places. Now, just to make sure that's all still working, we'll quickly deploy this system. There we go, and we'll switch over to the screen that comes with the example project. And you can see that we're generating a sine wave and a delayed sine wave, and it's got some random noise on it. And you'll have to take my word for it, but the analog output channel that I created earlier will also be outputting a similar sine wave. Let's just undeploy that for now. And if we switch back to our system overview here. So those are three ways of mapping channels. I'll now show you a fourth way, and that is, of course, to use the API. As with most functions in VeriStand, there's a .NET API that enables you to script the functionality rather than using the graphical user interface. So if we switch over to LabVIEW, I have an example here that is going to show you how to use the .NET API to script the mapping of channels in VeriStand. Now, like I said, this uses the .NET API, so any application that can call .NET, such as C or Python, can also be used instead of LabVIEW. In LabVIEW, you see we open a reference to the project, get to the root, then we tell it to clear the existing channel mappings, and then we're going to add new mappings. And we've got an array here of your sources and an array of destinations, using a very similar syntax as what we showed in the channel mappings tool earlier. Now, as I mentioned, you could also use a text-based programming language. So here's some pseudocode of what that could look like. Importantly, it's a .NET API, so anything calling .NET can call that. And we switch back to VeriStand, and we see all of our channel mappings here. Now, that was four ways of how to map channels in VeriStand. I hope you found this helpful. If you have any more questions or want to discuss further, please go to ni.com/VeriStand or contact your local NI representative for more information. Thank you.